Okay, for one, we just need to sketch a graph using the given information. So I always like to group like x values together. So I'll start off with x equals 0. That's definitely the weirdest one that we have going on here. And always best to start with plotting points. So f of 0 equals 4. So I'm going to have a point right there. And then it says from the right-hand side, it's going up towards positive infinity. Left-hand side, it's going down towards negative infinity. So that normally indicates the presence of some sort of vertical asymptote. This extra point here is really just there to trick us, I believe. So we have right-hand side up, left-hand side down. So that's going to take care of the x equals 0 stuff. Next is going to be x equals 3. I'll start off with the point. We have a point at 3, 0. From the left-hand side, we're approaching -2, so I'm going to just put a little point over here. Can't actually equal -2 because we already know it equals 0. Put a little tail on the left. From the right-hand side, it's up at 2. Same idea. Put a little circle at 2 because we already know what fills in there. Put a little tail on the right-hand side. Next, we have as x approaches 5, it's going to be up at 4. Okay, so that's way up here, and then it's 1, 2, 3, 4. All right, so I'll put a little point here, and since it's a real limit, it means from both sides. It's going that way and that way. And then we have as x approaches 4, as x approaches positive infinity, we're going out towards 4. So that works out nicely for us because we're already equal 4 right here. So I can just connect these guys right there at 4. As x goes towards negative infinity, this thing's going towards -1, so I have an arrow over here. So now I just need to connect the pieces. So this one connects to that. This is going to connect to that. This will connect to that. That point doesn't touch anything. That point doesn't touch anything. And this fits the criteria that we're looking for this particular graph. All right, as x approaches 2 from the right, it's going up, and 2 from the left, it's going down. That indicates the presence of a vertical asymptote. Okay, so I have down on this side and up on that side. Next, let's look at x approaching -3. We have a point actually up at 5, so that's like right there. And the limit from the left and the right is approaching -1, so that's going to be way down here. So I'm going to have an open circle with a tail on the left and the right, approaching 1. Next, we have as x approaches positive infinity, it's going towards 0, so I'll just put an arrow over here at 0. As x goes towards negative infinity, it's approaching 4, so I'll just put an arrow right there. Now I just have to connect the dots. So this one has to connect to this tail right here, this tail has to connect to that, and that has to connect to that. That point's just chilling there, not connected to anything. And there you have it. That's the potential graph. All right, so we're given a graph and we're being asked to find these limits. So we have -2 from the left-hand side, so that's right here, is approaching a height of 2. As we approach -2 from the right-hand side, it's way down here at -1. Those aren't the same number, so this does not exist. It is filled in at 2, so the limit, the actual function will be 2 there. As we approach 3 from the left, it looks like we're at a height of 0 from both left and right, which means the actual limit is also 0. However, our function is actually defined way down here at -1. Okay, and again, this just highlights the difference between the limit, which is the intended height, and f of 3, which is the actual height. As we approach negative infinity, it looks like we're going down, so we're just going to assume that there's negative infinity there, and here it looks like we're going up positive infinity. And there you have it. Alrighty, same idea for 4, as it's just things are a little bit out of order from the way the other questions have been, but we have as x is approaching negative infinity, it looks like we're going up, so that's going to be positive infinity. As we go towards x approaching positive infinity, it looks like this is going down, so I'm going to say negative infinity. Here we have -2 from the left, the right, and then the actual limit. So from the left, it looks like it's at a height of 1. From the right, it looks like -1. Those are not the same number, so the limit does not exist. As we approach 0 from the left and the right, both of them are converging on this -5. That means that the actual limit will also be -5, okay? And at 3, it looks like we got a vertical asymptote here. It's got weird graph going on here, I don't know, but it looks like it's going up towards positive infinity, which means that the actual limit is going towards positive infinity. And remember that technically this does not exist, but all math people in the world know that when we write infinity, it technically does not exist. Now, just to highlight real super quick some other things here, if I were to have asked, like here, what is f of -2? That is -1, because that's where the point is filled in. If I were to ask what is f of 0, that's going to be undefined because there is no value for it. Same thing with f of 3. There's a vertical asymptote here, so f of 3 would be undefined. So a limit can exist even when the actual function is undefined there. All right, for what I have labeled as 7, I feel like the numbering is wrong in this section too. I have no idea. We are given that this arbitrary function f of x at x approaching c is going to equal 4. G of x will be equal to 5. We're just using these properties. So this should be the easiest section. We just do 4 to the third, so that's 64. Done. This is 3 times 4 minus 5, so that's going to equal 7. This is 4 times 5. Pretty sure that's 20 last time I checked. And this is just 4/5. Done. Wow, that was super hard. All right, 8a. We tried direct substitution. That doesn't work, so next we're going to try the conjugate method. So I'm going to do the square root of 2 minus t plus the square root of 2 over same exact thing, just being lazy and not writing it. So when I FOIL on top, I will get 2 minus t minus 2. On the bottom, I'm going to leave this undistributed. So that's our shortcut that we always do, the things that actually conjugate. We don't bother with the bottoms. The 2's are going to cancel. T's are going to cancel. I'm left with a negative 1 over the square root minus each other. And we're doing limit as t approaches 0. Okay, so now we can direct substitute and see what we get. We'll get negative 1 over. All right, I had to pause there for a second. I wrote this wrong. This was plus, plus, plus. So this actually makes sense. Now I get square root of 2 plus the square root of 2. So this is going to be a negative 1 over 2 square roots of 2. Done. When I'm over here, try direct substitution. I get 0 over 0. That tells me I can try the factoring method. So I'm going to get x plus 2, x minus 1 over, what is this? X minus 2, x minus 1. So the x minus 1's cancel. I can now direct substitute. I'll get 1 plus 2 over 1 minus 2. That's 3 over negative 1, so this is negative 3. All right, for C, tried direct substitution. It did not work, so I'm going to multiply top and bottom by the conjugate. So x plus the square root over x plus this giant square root. I will actually distribute up on top, so I'll get x squared minus a 3x minus 2. That's in parentheses. That's mildly important. And on bottom, I'll just actually fully factor this and leave it. All right, so when I simplify this top part, I really have a negative 3x plus 2, so I can actually factor that. That's going to factor to x minus 2, x minus 1. So the x minus 2's cancel, so I'm left with x minus 1 over x plus 2 times this crazy, x plus 3x minus 2 business. And I believe I can direct substitute now. On top, I'm going to get 2 minus 1. That's going to equal some crazy number, right? Like 1. On bottom, I will get 4 times 2 plus 6 minus that is 4, so 2. All right, so this should equal 1/8. I can't do math. 4 times 4 is in fact 16, not 8. Whew, that was rough. All right, for D, I'm going to try to direct substitute in here. Doesn't work. I'm going to multiply top and bottom by 1 plus the square root of x. All right, so on top, I'm just going to factor that 6 out. Otherwise, I'm going to leave it factored like this. Bottom, I will actually distribute this. I get a 1 minus x. That's the opposite of that, so I'll have a negative. Forms negative 1. 1 plus square root of x. Now I can do limit as x approaches 1. So I get negative 6 times 1 plus 1, which is, last time I checked, negative 12. Okay, for E, tried direct substitute, did not work out. So I'm going to try to factor next. So I'm going to factor out a 3 there. That will give me t squared minus 16. So let's actually just keep factoring that. That's going to be t minus 4, t plus 4. This bottom part down here, I'm going to get 2t, and let's see, I need a 24, so that has to be 8. So this is going to be a minus 4 and a minus 3, I believe. Yeah, that sounds right. All right, so I'm going to cancel that out. 3 t plus 4 over 2t minus 3. Doing the limit as t approaches 4. Let's direct substitute. I get 3 times 8 over 8 minus 3. That's 5. So I should get 24 over 5. This guy, try direct substitute, get 0 over 0. So I'm going to factor top and bottom, and I'll be able to cancel out one of the x plus 1s. I'll be left with an x minus 1 over an x plus 1 to the 4th. Now I get a number over 0 when I direct substitute. That indicates vertical asymptote. So I'll just super quickly sketch a super rough graph of this stuff and I will end up with something like this. So since these are both going down towards negative infinity, this is going to be negative infinity. All right, for g and h, they're giving us one-sided limits, which almost always means that it's going to be at a vertical asymptote. It's just like a little math teacher type of thing to do. So let's try this. If I plug in 2, I think I get a number over 0, but I'm pretty sure that this actually factors to be something that will cancel and make our lives a little bit easier. So yeah, those do. We get 1 over x minus 2. So that's much easier to graph. I know I'm going to have vertical asymptote at 2. I have a y-intercept at negative 1/2. I have no x-intercepts and a vertical asymptote right there. So this is going down, and that's going to be up there. I'm looking at it from the left. It's going down towards negative infinity. So I get negative infinity. H, same exact idea. This time there's nothing that's going to cancel. I'm just going to do a quick sketch of this thing. This actually does become x minus 5 squared. That makes life a little bit easier. So I have a vertical asymptote way over here at 5, multiplicity of 2. I'm going to have square root of 5 plus and minus. I know that those are less than 5. Square root of 25, square root of 5. One's bigger than the other. And let's see, I'm going to have n behavior asymptote up here at 1. And a y-intercept at negative 1/5, I believe. Yeah, so I think it's right there. So this is going to go like this, and then like this. So this is asking me from the right-hand side. This is going towards positive infinity. I and j are both using the trig properties that we have to memorize. First thing I'm going to do is factor a negative 1 out of the top. And that will give me 1 minus cosine x. And on the bottom, I'm just separating the 3 and the x. Limit of a constant is always that constant. 1 minus cosine x over x, as x is approaching 0, always equals 0. So 1/3 times 0 is 0. Over here, same idea. I'm going to factor out that 5. So I'll have 1 minus cosine x over x times this 5. 5 times this is going to be 0. Get 0 again. Here I will separate this out into 3 times sine x over x times cosine x. Limit of a constant is that constant. Sine x over x as x approaches 0 is going to be 1. That's one of the ones we memorized. Cosine of 0 is also 1, so this is 3. L is a tricky one. We got this 2x in here, so what I'm going to start off with is I'm going to let u equal 2x. Alrighty. And I'm going to try to modify this limit. So if x is approaching 0, I need to know what 2x is approaching. It's also approaching 0, which means u is approaching 0. So I'm going to rewrite this limit as the limit as u approaches 0 of sine of u. Now this x here, what I really need to do is solve this and say that this is really x equals u over 2, so this would be u over 2. And when I simplify that, that puts a 2 up top. So I get sine u over u, limit as u approaches 0. Alrighty, then we can separate this out. This is 2 times sine u over u. Limit of a constant is that constant. Sine u over u, as u is approaching 0, is 1. So this is going to equal 2. Woo! Alright, for a 9, we're just evaluating the limit as x approaches positive and negative infinity. So I'll start off with x approaching positive infinity. So that's going to be, what is this? This is 2. Oh my gosh, math is hard. This is 2 times infinity minus 7 to the infinite power all over 6 times infinity minus 7 to the infinite power. So things to the infinite power are always bigger than not, so I can basically ignore those. These happen to be the same number, so this is going to be approaching 1. When I do negative infinity, some things change. I'm going to get 2, negative 2 infinity minus 7 to the negative infinite power. And that's the thing that's gonna change things for us. So this 7 to the infinite negative infinite power is really 7 over, I can't talk, it's really 1 over 7 to the infinite power. That's really 0. So in this time, these guys drop away. So we're really left with negative 2 infinity over negative 6 infinity. Infinities cancel, positives cancel, and we're left with 1/3. Boom. Done. Let's do the same exact idea over here. Infinity, we'll get 2 to the infinite power over infinity to the 20th plus infinity squared. Infinity squared is so much smaller than infinity to the 20th, so we ignore it. Anytime infinity is in the exponent, that's the bigger number. So bigger numbers on top, that's going towards positive infinity. As x goes towards negative infinity, things are going to change. We'll have 2 to the negative infinite power all over negative infinity to the 20th plus negative infinity squared. This up top is approaching 0. So this is going to be 0 because the numerator is going to be 0. Don't need to bother evaluating anything else on the bottom. All right, we'll plug in positive infinity for this. that's going to, I'm just going to drop this to the bottom. This is really x plus 5 squared. So whether I plug in positive or negative infinity, both times this thing is going to be approaching 0, okay? Because I'm going to end up with 1 over an infinitely large number. So done. I'm not even going to bother with the rest of it. This guy over here, this is the type that math teachers like. We have 7 minus 6 to the infinite power over 6 to the infinite power minus 4. The 7 and the minus 4 don't really matter. So we have negative 6 infinity over 6 infinity. That's going to be negative 1. When we plug in negative infinity, though, things change. So I'm going to end up with this. Now, 6 to the negative infinite power, that's actually 0, because that's actually 1 over 6 to the infinite power, which is approaching 0. So this time, these drop out, and we're left with 7 over negative 4. Sign is always between negative 1 and 1, no matter what's going on with it. So this is always a small number over x, okay? And when x is going towards infinity, we have small over an infinite number, either positive or negative. It's going towards 0 for both of them. So both x approaches infinity and negative infinity are going to be approaching 0. When I'm over here, we can use that same exact idea. This is always a small number between negative 1 and 1. So I will have infinity over infinity equals 1 for the first one, and I'll have negative infinity over negative infinity, which still equals 1 for the next one. So in either case, this is approaching 1. All right, this giant piecewise. I'm going to first just label all of these things, A, B, C, D, and E, and then look at these. They go vertical, which is different than I think we did in the practice packet. So negative 1 from the, let's see, this is tricky, this is backwards. From the left is in A, from the right is in B, okay? There we go. Let's see, positive 1 from the left-hand side is in B, and from the right-hand side is in D. Okay, f of 1 would be in C. So we can basically ignore that in terms of this stuff. And then what's going on with these ones? I didn't write them correctly. My bad. We got a bunch of ones over there. I'm just going to write them way down here. We got x approaches negative 3. We have x approaches 5. And we have x approaching 1.5. So let's see. Negative 3, that's very firmly in A. 5 is in E. And 1.5 is in D, okay? So let's just separate those things out real quick there. So let's evaluate this. Let's look at this one right here. So B, when we're going into negative 1, well, that's always 2, right? There's nothing there, so that's just 2, easy peasy. Negative 1, when I go to plug it in here, I'm going to get 1 over negative 1 squared, which is just 1. So this should equal 1. Those are not the same number, so the limit does not exist, as Lindsay Lohan taught us in Mean Girls. D, if I plug in positive 1, okay, I'm going to get 2. In B, if I plug in positive 1, I also get 2. Those are both the same, so the real limit exists at 2. Whew, that was not that bad. Up here, if we look at A, we plug in negative 3, that's going to give us 1/9. Since we could direct substitute, that's the actual answer. If I plug in 5 in for E, I'm going to get negative 1 over 3 squared, so that's going to be negative 1/9. I could direct substitute, so that is the actual answer. And then up here, D, 1.5 plus 1, that's going to be 2.5, and I could direct substitute, so that's the actual answer. Whew, and there we go. That's it. We're finally done. That took forever.